everyone, Mr. O'Keefe. I just wanted to go over this problem called John and Jermaine in our unit on right triangle trigonometry. This is how you would find the height of, in this case it's a helicopter, using indirect measurement. So the first part of the question asks you to write an equation where you use these two triangles. There's a blue one, the large triangle, and a red one. Okay, so this is where Jermaine is standing down here, and this is where John is standing. So the situation is that John and Jermaine are 10 meters apart, and John is at unknown distance from being right directly under a helicopter. And the goal is to find the height of the helicopter using indirect measurement. So the first part of the problem is to write your equations so that you have two equations that try to determine the height, x, given the information that you have. So the first one we're going to use is for John. Okay, and that's the red triangle. So with John, I have a 55-degree angle. I have an opposite side called h, and an adjacent side called x. So opposite and adjacent in our trig functions is the tangent function. So we're going to use the tangent function of the angle that we're working with, 55, and set that equal to the ratio of how those sides relate to that angle. And the tangent function is the opposite, h, over the unknown value, the adjacent side, which is x. So then, when you isolate h and you cross multiply, you get h equals the tangent of 55 degrees times x. I cross multiply. At the same time, if you want to try to write another equation for Jermaine, we're working with a 48-degree angle this time. This is again the large triangle, not this obtuse triangle, but the whole triangle, still working with right angles. Still working with the opposite side, which is h, and the adjacent side, which is now x plus 10 or 10 plus x. So x plus 10, the whole length of the bottom is the x plus 10 more. So that's still the tangent function. So now when I cross multiply and I try to solve for h, I get h equals the tangent of 48 degrees times that distance, which we're calling x plus 10. So I think it's important to understand that they're both measuring or set up to find h. And that h value is not going to change. So h is equal to h. So the value that's equal to h, in this case, the tangent of 55 times x, is equal to, from Jermaine's perspective, the tangent of 48 times x plus 10. So now I've written an equation with one variable using indirect measurement. So h is now out of that equation. So let's move it up here. I'm going to change the tangent of 55 to its ratio. So 10, 55, I'm going to round that to 1.428. So I have now 1.428 times x, which before, remember, was just the tangent of 55, and set that equal to, instead of the tangent of 48 now, instead of the tangent of 55, I'm looking for the tangent of 48. So the tangent of 48 is 1.111. So the tangent of 48 from before now that is 1.111. And I'm still multiplying it, like before, x plus 10 times that length. So now I need to distribute this 1.111 to both terms inside the parentheses. So when I do that, the left side stays the same, 1.428 times x. The right side now becomes 1.111 times x plus 1.111 times 10, which you just move the decimal one place. So I'm moving that decimal over one place. So I have 11.11. That's my whole number. So now I have a two-step equation where I'm solving for x. So I'm going to subtract 1.111x from both sides and combine my like terms. Here's my equal sign. So I have x. 8 minus 1 is 7. 2 minus 1 is 1. 4 minus 1 is 3. Here's my decimal point. Okay. And then on the right side, I still have 11.11. Same process for solving a one-step equation. Divide by your coefficient, in this case 0.317 on both sides, 0.317. When you divide by a decimal, the original number gets bigger. Okay, so 11.11 divided by 0.317 puts me at 35.05. 35.05, and that is equal to x. So now I found x. This allows me to do by finding x is subbing it back into these equations. So I can sub x in here with John. I can sub x right in here with Jermaine. So now this equation becomes the tangent of 55 is equal to h over, and now it's 35.05. Cross multiply, h is equal to the tangent of 55 times 35.05. Tangent 55, close my parentheses, times 35.05. I end up with an h value that is 50.06. Shifting gears here, same exact process. Now I have this equation, the tangent of 48 equals h over, and then x is 35.05 plus 10. Cross multiply, h equals the tangent of 48 times 45.05. I just added 10 to my original number. So we're going to go back up. I'm going to have this be 48. Now is my tangent, my reference angle. And then I have 45, and I get 50.03. So h equals 50.03. So now I need to make a claim. So the claim, based on all this evidence, is what I believe to be true. The helicopter is 50 meters off the ground. I hope that helps. I hope that makes some sense.